This is the Belgium number 8 pilot, IMEC. The pilot is located in the University of Antwerp campus of Drieken. We have available a student's residence where the white goods will be installed and monitored. The main goal of the pilot is to reduce the electricity consumption by following a gamification approach so that students receive notifications and rewards to do laundry when the electricity price is lower.
The Belgian pilot managed by Thermovault has 70 apartments. The main pilot's goals are to reduce energy consumption, energy cost, and carbon footprint. To achieve these goals, energy efficiency, peak shaving, and self-consumption services are offered by optimizing the electricity consumption for domestic hot water and space heaters.
This pilot is taking place at the Energieville Thor Research Park in Henk, Belgium. The main goal is to demonstrate interoperable EV smart charging optimizations and flex service provision that considers dynamic charging capacity constraints, uncontrollable load and local PV production forecasts, and dynamic and time of use and peak prices.
This pilot is taking place at the Cordium social housing site in Hasselt, Belgium, consisting of 20 apartments connected to a heating network. The main goal is to demonstrate an optimal coordination of space heating and sanitary hot water production among the virtual energy community members with respect to the use of shared PV, PVT and thermal storage.
Welcome to the Nieuwe Dokken. We're currently in one of the newly built apartments at the Nieuwe Dokken, right next to the technical room. This is where one of the smart white good appliances will be installed, a washing machine. And these are the OpenMonix gateways that we will use to communicate with the smart appliance and to control it.
This is the 6th Belgian pilot NanoGrid. The pilot is located in Belgium and focuses around a small energy community fully behind the meter. The main goal we want to achieve within the InterConnect project is exploring a flexible peer-to-peer marketplace while giving our user the possibility to opt out of the community.
This is Belgian pilot number 7. Winkenbusch elderly home by 3E. The main goal is to implement a smart energy and flexibility management system for peak shaving, self-consumption, and explicit flexibility.
Hello, this is one of the Belgian sub-pilots managed by VUB and installed at the Green Energy Park in Brussels. Inside the Smart Village Lab, we have 6 virtual houses that each have a different commercial solar system, energy management system, and home battery system, and soon also a white good device. These will all be trading energy with each other through the peer-to-peer trading market coming from InterConnect. They will also be offering flexibility services through the interoperability framework.
Hello everyone, in this short slide set I will introduce you the Daikin heat pump proof of concept evaluated in our IMEC pre-test lab called the Home Lab. We evaluated the architecture depicted in this figure. The HVAC device, the Daikin heat pump, is connected to the Kio Edge device. Together with the Edge device there is also the Kio SSA adapter connecting to the knowledge engine where two services, the LPC, the limit of the power consumption, and the MPC, the monitoring of the power consumption, are executed. The evaluation is done as follows. The InterConnect SSA and services Raspberry Pi sent an LPC request to the knowledge engine. The knowledge engine sent this request to the SSA running on the Raspberry Pi, followed by the SSA that is sending this request to the Kio Edge device, and the Edge device will send that request to the heat pump itself. On top you can see the LPC service, so we sent a limit of 1000. The knowledge engine receives this request and post it to the SSA, and the SSA is receiving the request. The Kio Edge device is accepting the request from the SSA adapter. These are the results from our measurements. From the red line you see that the power consumption is limited to 1 kilowatt maximum. Sometimes there are spikes above it, but it's because of the pumps that needs to be activated and they are requesting a little bit more power than 1 kilowatt.
This video is a short introduction to the PV forecasting service that is offered by OpenMotics in the context of the InterConnect project, and that is making use of the semantic interoperability framework. Important to mention in the context of this demo is that I will be taking the role of a third-party service user. That means in practice that I will be executing code locally. I also have a generic adapter instance running locally on my laptop. Anything else that you see in the figure is either running in the InterConnect cloud or in the OpenMotics cloud. Now, to make use of our PV forecasting service, we first need some input data. In our case, this is weather predictions. And then you also need a PV installation ID of the specific PV installation configured in the OpenMotics backend. Now, when I execute a post request to the generic adapter, which forwards it throughout the semantic interoperability framework, we see that we get back a response that indeed contains the predictions of the PV production for the coming 3 hours in this case.
This is Thor Park, a former mining site turned into a research and business park. It consists of several buildings and parking lots. The demo in this video focuses on the flexibility interaction between the building energy management system of the Energieville 1 building and the flexibility aggregator. The main flexibility is provided by 22 charging poles of different brands. The driver connects its car, uses its badge for identification, and provides its departure time and requested amount of energy in the smart charging app. During the charging, the user can monitor the charging sessions or alter the preferences. Every 15 minutes the building energy management system will provide a planning for all controllable assets for the next 24 hours. This planning is the result of an optimization to minimize costs, maximize PV self-consumption, reduce the power peak and maximize the user comfort. These schedules are then sent to the charging poles. By means of post-knowledge base interactions, the building energy management system of the Energieville 1 building publishes its active power measurements, the baseline forecasts and its potential flexibility via the interoperability framework to the aggregator. After processing the flexibility offers, the aggregator can decide to activate flexibility by posting a flex activation knowledge base interaction request to the building. This request will be incorporated in the next optimization round. This is a live demo of the flexibility exchange interactions between the building energy management system of the Energieville 1 building at the Thor Park pilot and an aggregator client. The building energy management system, the generic adapters and the knowledge engine of the interoperability framework are already up and running. At the left side of the screen, one can see the service-specific adapter that connects the building energy management system to the interoperability framework. It provides all the knowledge interactions for the flexibility information exchange. The service-specific adapter of the building energy management system is started, registers the flexibility knowledge base and its knowledge interactions, and starts publishing active power measurements, baseline plans and flexibility forecasts via the interoperability framework to the aggregator. The right side of the screen shows the flexibility aggregator. In InterConnect this is CyberGrid, but for demo purposes it is represented by a Node-RED client here. To connect to the interoperability framework also this client registers at the service store, registers the knowledge base and associated interactions, and starts listening for incoming knowledge interactions, posted by the building energy management system. Looking for instance at the received active power measurement we see the actual power consumption of the building site. Upon receiving the plans the aggregator can decide to activate this provided flexibility by posting a flexibility activation request. When this request is received at the building energy management system side, it will be incorporated in the next optimization rounds. To clean up the demo we register the knowledge base.